topology. I will describe the different topology of the uh, for use for the converter. Power electronics in electric vehicles. There are different type of power electronic devices are used for the electric vehicles or industrial also, and different type of power electronic devices also. Among the existing power electronic devices, including thyristor, GTO, bipolar transistor, BGT, MOSFET, IGBT, and SEET, MCT, MTO. That uh, Mainly, the LGBT is almost exclusively used modern electric vehicle system. Nevertheless, power MOSFET also be has been accepted for the low voltage, low power electric vehicle system also. The power converter topology normally follow the that power devices aiming to achieve high power density, high efficiency, high controllability, and high reliability. And the selection criteria of motor drives, including motor, their power converter have to selection by using of the drive of a system. Which type of drive you have to use? That is that using that way, you have to select the power modulator or power converter. Now, in order to accomplish growing the power demand EV and design and the integration power electronics component electrical and mechanical load vehicles become essential. Available power electronics converter include DC to DC converter, rectifiers, inverters, battery charger composed to the AC to DC and DC to DC converter. And the other different other type of also, that means mainly multi-level inverter may be also used. Now, the architecture of power electric vehicles, among them EB, ACB, PACB, and FCB, each member has its own capability and limitation in terms of emission rate, performance, fuel economy, size, weight, loss, safety, and comfort. Actually, integration automobile technology or electrical adds to complexity control, make the high hybrid electric vehicles system comparatively bulky and costly. At present state, HEB has seen the promising technology which is growing rapidly and capturing the significant marketplace at the fastest. And also plug-in HEB also be used. These are the different architecture where power electronics converter are used. Here, power electronics converter everywhere, parallel hybrid, series hybrid architecture, their power electronics converter are used. And another architecture for different technology, that means series parallel, their power electronics converter are used. These are the different architecture where all power electronics converters are used for the controlling. The electric propulsion system, there are two popular configuration interface. The energy source system, inverter motor is considered bigger. High voltage. Figure one is high voltage ESS, and it is for the low voltage ESS are used. So high voltage ESS are used, and this is the DC link capacitor, and then an inverter converter, DC to AC converter, and traction motor. And here also we have to using the low voltage low voltage ESS, that and bidirectional converter, DC to DC converter, and it will be the distilling capacitor, and similar to the we have to consider. So now this is the power electronics modern architecture of electric power system vehicle. That means we are considering here that we are considering that in advanced architecture of vehicles electric power system, it is expected to have single DC voltage bus with different voltage level distribution and intelligent power load management. Then the in this architecture, different energy sources and vehicle loads having a distinct VI characteristic and dynamic response are getting preferable are getting preferable. Now here we are considering the different case of IC engine generated DC, AC to DC converter, then DC bus voltage. Similarly, then battery pack, and that case we are considering the, that means we are considering alter capacitor and fuel cell, that and PV cell. Then we are a converter, DC to DC converter, and DC was cell, DC to AC converter, convert to this one, and everywhere a DC to converter are used for these cases. Now I am discussing more important converter. There are different type of converter may be used. DC to, I already told, DC to DC converter, AC to DC converter, and DC to AC converter. Actually, some cases, very little cases are only AC to DC are used. Every cases are using DC to DC converter. DC to DC converter is a it is a device which can convert unregulated voltage, certain level and regulated voltage, and DC output voltage different level is high conversion efficiency. Uh, and modern days DC to DC converter can operate at high frequencies. DC to DC convert power electronic which convert fixed voltage to output voltage. It is also high speed on off semiconductor switch. That means the output voltage can be controlled by using switching on and off of any switching semiconductor switch. The semiconductor switch may be used ACR's group, ACR's power BGTs, MOSFET, IGBT used in shopping circuit, and the switch turn on and turn off by the pulse width modulation techniques. DC to DC converter are significant, especially in terms better utilization of energy sources, power management, dynamic flexibility, and system optimization, reduction of weight and cost loss. And the advantage of DC to DC converter: high efficiency, losses are low, faster response, less maintenance, small size, speed control, and low cost. For this purpose, that is why nowadays DC to DC converter are used mainly. Most are used for the electric vehicle system. DC to DC converter electric may be used for this three condition also. I am not discussing. This is the DC to DC converter system where we are considering the uncontrolled rectifier. Then uncontrolled rectifier will give the unregulated DC. Also, we have to use the battery and filter. Then DC unregulated DC to converter, we are getting the regulated DC voltage. This is the block diagram of linear power supply. These are already unregulated. This is unregulated with diode rectifier and the capacitor. This filter also or digital capacitor also you have to using that. Then base gate drives error amplifier also that DC regulated we are getting here. And when we are using the isolated DC to DC isolated, then we are using this is the also it is known as a SMPS switch mode power supply. That is the diagram. That means EMI filter and rectifier and filter that are considering the total converter isolation with isolation, and this is high frequency rectifier and filter. Then we are getting the DC regulated and error also going to this. This is the power PWM controller and base. It will be control the switch, base control of the switch. There are different type of DC to DC converter are available. Maybe we'll discuss here buck boost and buck boost, and different type of isolated half bridge, full bridge, forward like I will discuss, and soft switching also I will discuss resonant converter, the ZCS and ZBS, and control of DC to DC converter pulse width modulation. Hmm. Control of DC to DC converter or pulse width modulation. Actually, we are controlling desired voltage and using the voltage and then the actual voltage. Then we are going to the using the op amp. Then we are getting B control. Then P control are sawtooth. We are using the comparator. Then we are getting the signal. That at the we are considering the B control one and B control two, and it will be controlling with that. then you have to changing this control voltage with compare with the sawtooth waveform. Then we are getting the gate pulse. That means it is the one period will be changing with the control b control, changing the b control. We have to design this also. We have to design by hardware. I have already designed on one or two or three PWM control for my setup. uh, I am discussing buck converter. Very buck converter actually the output voltage will be less than the input voltage. That means we are considering that yeah, that buck converter also this type of DC to DC converter mainly used for the speed control of DC motor. So when we are considering the consider the buck converter, then the output voltage will be always less than, because that will be I will discuss due to the changing of turn on and turn off condition. So now this is the circuit diagram of buck converter. And when switch going to the off condition, closed, switch going to the closed, and diode is going to the reverse, then we are getting the current flowing through this path. And when the switch is off condition, that time that we are getting this on voltage. And when the off condition, that means it to switch going to the off and diode going to the on forward bias, then current also flow. That means the output voltage you are getting this one. So now when switch closed, and this is the current waveform, that will be the maximum and minimum current for inductor current. And inductor current will be going to the increasing, and it will going to maximum. After off condition, it going to the decreasing. So when switch going to the closed, then BL, we have to write BD minus B0 equal to LDIL by DT. From here, we have to write DIL equal to BD minus B0 by L. So now DIL equal to, also you have to write del IL by del T. Del IL by del T equal to represent as KT. Then we BT minus B0 by L. Here we have to write down del IL on equal to BT minus B0 by L dot KT. And when switch going to off condition, BL equal to minus B0, then we have to write DIL by dt equal to minus V0 by L. Then DIL by dt, that means to off condition 1 minus KT, 1 minus KT, that will be off condition 1 minus KT. Then we have to write del IL off equal to minus V0 by L 1 minus KT. So now steady state operation IL at the end of switching cycle is the same as the beginning of the next cycle. Then the change of the IL over one period is 0. Then we have to write this del I1 plus this equal to 0. Then from this equation we have to write B equal to K BD, where K is the duty cycle. Where K is the duty cycle. Now you have to change K value 0 to 1. Then the output voltage will not increase. It will be the decrease. Then now this is the from the current waveform. From the current waveform, the inductor current, average inductor current equal to the average load current. Then you have to return that B0 by R. Then I maximum equal to IL plus del IL. IL plus, we have to considering the del L plus I del L plus 2. So from here, you have to write this equation. Then you have to find out I maximum. And similarly, you have to find out IL minus del IL by 2. You will find out that then del IL equal to I maximum by I minimum. You are getting the ripple current, inductor ripple current B0 1 minus K by LCF. Now, the equivalent circuit we are considering for finding out the capacitor current. So IC equal to IL plus IR from this circuit. Then the Q equal to CB, everybody knows that the charge, and when we are considering the small del q, and we have to write this one del v 0 by del q by t, then del q equal to half t by then 1, then that one equal to del il, and del v 0 equal to, you have to write this one. From here you have to find out the ripple can be reduced by increasing switching frequency, increasing inductor size, and the ripple factor is, we are considering this equation 1 minus k 8 L f c square f square. Then these three terms are very important to deal with the ripple. Now I am discussing the boost converter. Boost converter is a converter, DC to DC converter, which the output voltage is more than the input voltage. That will be given the changing the switching on off of the, because on off of the switch. So now this is the circuit diagram of boost converter. Inductor is connected before that. That means the when switch going to the on, that will be, the current flow, and this will be diode going to the off, only off. That means, and simple we have to consider the when it is going to off condition, then output voltage and waveform we are getting this one BL equal to BD first when switch going to the on. Then from this equation we are get del IL, see previous one, just like as a buck converter, BD KT by L. Similarly, in on condition, off condition, we are getting del IL of BD minus B0 by L1 minus KT. Now, in similar way, del L plus then you are getting B0 equal to BD by 1 minus K. Now, we have to put the value of K, the output voltage will be always the increase. Now, now, now the we have to considering the input power equal to output power. From here the BD equal to that case, and BL at that, from this we have to find out also the average inductor current BD equal to 1 minus K square R. So inductor current also you have to find out by using uh,
Sir, we are not able to hear you. Please check whether you have muted your mic. No audio.
Yeah.
Professor, you are not audible. Please check your mic. We are not able to hear you, sir.
Sir, no audio.
Sir, participants are not getting your audio. Maybe your microphone is muted.
Sir, no audio, sir.